Good evening and thank you for tuning into this video. So tonight we're just going to quickly review what we did earlier today. We were working on solving absolute value equations, and then I just wanted to work a couple more examples for you. So just to review from earlier today, to solve an absolute value equation, you isolate the absolute value expression, and then you write an equivalent pair of linear equations. So let's look at this first example. The absolute value of x plus 7 is equal to 9. To solve this equation first, you have to isolate the absolute value expression, which is right here. So I'm trying to isolate this part. So first thing I want to do is subtract both sides by 7. And then when I do that, I get the absolute value of x is equal to 2. Now remember, the absolute value of x means that x is a distance of 2 units away from 0. So I actually have two solutions here. Because if x is 2 units away from 0, x could be at -2 or it could be at +2. So now I can break this up into two different equations. I could have x is equal to 2 or x is equal to -2. Because both -2 and 2 are 2 units away from 0. If I wanted to graph it, I'll draw my number line. Here's my -2, here's my 0, and here's my 2. And then my solution would be 1 would be at 2, and 1 would be at -2. So in this case, my two solutions would be x is equal to 2, x is equal to -2, and that would be my final answer. So that was just a review of what we did today. I wanted to work a couple more examples that are a little more complex. Just move my paper up. So the next example is the absolute value of x minus 8 minus 2 is equal to 8. So again, first thing I have to do is I have to isolate the absolute value expression. So my absolute value expression is going to be the absolute value of x minus 8. So I'm trying to isolate this piece right here. So the first thing I have to do is I have to first add both sides by 2. So I add 2 over here, and I also have to add 2 over here. So now I have the absolute value of x minus 8 is equal to 8. Now at this point, my absolute value expression is isolated. So I have to think, okay, x minus 8 is going to be 8 units away from 0, which means I actually have two equations here, because x minus 8 could either be 8 or it could be -8. Because of my absolute value symbol, I just know that what's inside this absolute value symbols is 8 units away from 0. So I have to separate this into two different equations. So as I said earlier, x minus 8 could equal 8, or x minus 8 could equal -8. Okay? And again, I have to do that because once I isolate the absolute value expression, well, absolute value just means the distance away from 0. This distance, x minus 8, this distance away from 0 is going to be 8 units. So I have two possibilities because both 8 and -8 are 8 units away from 0. So because of that, I have to set up two equivalent, I have to set up an equivalent pair of linear equations. I have this equation right here, and then I also have this equation set to -8. So I'm actually going to have two solutions just like I did for the first example. Now, to solve this first equation, I just have to add 8 to both sides. So x could be 16. And for my equation x minus 8 is equal to -8, I'm also going to add 8 to both sides. But I get a different x value. I get x is equal to 0. Okay? So now, for my original equation, I actually have two solutions. My one solution is x is equal to 16, but the other solution would be x is equal to 0. So I'm going to go ahead and graph that on my number line. I'm going to put 0 right over here and 16 over here. And I'm just going to go ahead and fill in the dots. So my two solutions is x is equal to 16 and x is equal to 0. And if you plug the 0 and 16 back in, it makes sense. If I plug 0 in for x, I get the absolute value of negative 8. Well, absolute value of negative 8 is just 8. Same thing for the solution of x is equal to 0. I can go ahead and plug that in as well. When I plug that in, I have 0 minus 8, which gives me negative 8, and the absolute value of that is just 8. Let's go ahead and try one more example to make sure we're clear on the process. So here, I'm going to move my paper up for example 3. Okay, so here I have 1/2 times the absolute value of 2x minus 8 is equal to 5. So again, first thing I have to do is I have to isolate my absolute value expression. So I'm trying to isolate this guy right here. I'm trying to isolate the absolute value of 2x minus 8. To do that, I have to multiply by 2 on both sides. When I multiply by 2 on both sides, I'm just left with 2x minus 8 over here. And on the other side, I'm just left with 10 because 5 times 2 is equal to 10. Now, once again, I'm going to have to write two equations because I know that that 2x minus 8 is a distance of 10 units away from 0, which means that 2x minus 8 could either equal 10 or negative 10 because both of those values are 10 units away from 0. So I have to set up my two equations. One equation is going to be 2x minus 8 is equal to 10. And my other equation is going to be 2x minus 8 is equal to negative 10. All right, now I just have to solve both of these equations in order to get my two solutions. So for this first one, I'm going to just add 8 on both sides. And I get 2x is equal to 18. All right, now I just divide both sides by 2. So my one solution is x is equal to 9. I'm sorry my handwriting is so bad, but I'm writing this at an awkward angle. So my other equation is 2x minus 8 is equal to negative 10. And again, I have to set it equal to both 10 and negative 10 because both 10 and negative 10 are 10 units away from 0. So when I have an absolute value symbol, I end up having to set up two equations because I have two different solutions. Now for this one, I'm just going to add 8 to both sides. So I have 2x, negative 10 plus 8 is just going to be negative 2. So I have 2x is equal to negative 2. Then once again, I divide both sides by 2. And when I divide both sides by 2, I get x is equal to negative 1. So I have two solutions. One solution is x is equal to 9. And my other solution is x is equal to negative 1. So I draw my number line. My negative 1 is right here. And my 9 is right here. And then I'm just going to dot in at negative 1 and make a dot at 9. So those are my two solutions. And once again, if you plug it in, it makes sense. When you plug in negative 1 for x, you get absolute value of negative 10. Well, the absolute value of negative 10 is just 10. I can do the same thing by plugging in my solution of x is equal to 9. When I plug in 9 in for x, 2 times 9 is 18. 18 minus 8 is 10. Or sorry, 18 minus 8 is 10, and the absolute value of 10 is just 10. So both of these solutions would work for x. You have a couple practice problems on the back to try, and then we will be going over those tomorrow morning. God bless you and have a good evening.